Hello, everyone. My name is Don Wan Saw, and I'm currently a student in Biology 101. Today, I'll be giving an informative presentation on a critical topic in both medicine and public health, vaccination. Most people do not like vaccination. The first thing we are exposed to as a baby is vaccination. I was traumatized when I first received my vaccination as a child. However, researching the history and purpose of the immunization assured my health and others' well-being. Vaccination is one of the most effective strategies in modern medicine for preventing and controlling infectious disease. The primary purpose of the vaccination is to stimulate the host immune system to recognize and respond to specific pathogens, such as viruses or bacteria, without causing the disease itself. This is achieved through the administration of antigenic substances, typically an inactive pathogen, an attenuated strain, or molecular components such as protein or nucleic acid that mimics a natural infection and elicit an immune response. The immune response induced by vaccination involves the activation of both innate and adaptive immunity, leading to the development of the immunological memory. Upon exposure to the actual pathogen, the immune system can mount a faster and more robust response, thereby preventing infection and mitigating disease severity. Plotkin et al. 2018. Understanding the biological mechanism by which vaccines confer protection is essential not only for improving current vaccination formulation, but also for guiding the development of new vaccine against emerging pathogens. In this context, the study of vaccine-induced immune response offers critical insight into host pathogen interactions, immune memory formation, and the development of long-term immunity. Vaccines are a powerful tool that helps protect the body from infectious disease. They work by training the immune system to recognize and respond to harmful pathogens like viruses or bacteria without causing the actual disease. The history of vaccines spans over 2 centuries and represent one of the most significant events in public health. According to Montero et al. 2024, the origins of vaccination track back to 1796, when Edward Jenner used material from cowpox liaison to protect individuals from smallpox. This revolutionary method laid the foundation of the field of immunology. Jenner's work marked the first scientific attempt to include induce immunity against a specific disease intentionally. Later in the late 1800s, Louis Pasteur expanded upon Jenner's discovery and developed vaccines for diseases such as rabies and anthrax. He also introduced the concept of attenuation or weakening of pathogen, which became central to many future vaccines. As Montero and colleagues emphasized, the 20th century witnessed a dramatic expansion of vaccine development, particularly in response to devastating diseases such as diphtheria, tetanus, and polio. A significant milestone occurred in 1955 when Jonas Salk introduced the first successful inactivated polio vaccine, which helped reduce polio cases worldwide. In the decades that followed, vaccines were developed and distributed for measles, mumps, rubella, MMR, hepatitis, and influenza, significantly lowering global disease burdens. Most recently, the COVID-19 pandemic accelerated vaccine innovation, particularly with mRNA vaccine technology, which allows scientists to develop and distribute vaccines in record time. This modern advancement represents a shift towards faster and more adaptable vaccine platforms. Montero et al. 2024 note that these historical milestones are not merely medical triumphs but also they are reflect shifts in how society perceives public health, prevention, and immunity. In short, from Jenner's cowpox experience to today, genetic vaccines, the history of vaccination demonstrates how science has evolved to meet the world's most pressing health challenges. Vaccines have played a vital role in reducing mortality, eradicating certain disease and shaping global health outcome. Vaccines work by training the immune system to recognize and fight off harmful pathogens without causing the actual disease. This process begins when the vaccine introduces antigen into the body. These are small, harmless components of a virus or bacterium, often protein, that the immune system can recognize as a threat. Once introduced, the immune system responds by creating antibodies, which are proteins that neutralize or destroy the invaders. Most importantly, the body also produces memory cells that remember how to fight the pathogen in the future. If you're exposed to a real disease later on, these memory cells enable your immune system to react more quickly and effectively, often preventing illness entirely. To trigger this immune response safely, different type of vaccines employ various technologies, such as live attenuated vaccines, which utilize a weakened version of virus. Inactive vaccines use a virus or bacteria that has been killed. Subunit or protein-based vaccines use only specific part of the pathogen. mRNA vaccines, such as those used for COVID-19, instruct cells to produce a harmful vital protein that stimulates immunity. All of these vaccine types are carefully tested for safety and effectiveness. According to the Zhu et al. 2021, modern vaccines are among the safest medical intervention available. The article addressed public concern explicitly about ingredients like aluminum, adjuvant, and preservation, such as thimerosal. Zhu and colleagues found no reliable evidence that the component posed significant health risk. They emphasize that such ingredients are used in minimum amounts that are well within the safe limit. Importantly, serious side effects from vaccines are extremely rare, and vaccines continue to be monitored for safety even after they're approved for public use. This ongoing surveillance ensures that the immune system is being trained effectively without compromising safety. In summary, vaccine helps the body recognize and fight disease by generating antibody and memory cells. And as confirmed by current scientific research, including the work of Zhu and colleagues, they do so safely and reliably, protecting both individual and community from serious infectious disease. Vaccines can be developed in several different ways, each using a unique method to safely train the immune system to recognize and fight harmful pathogens. These approaches vary in how they introduce antigen, the part of pathogen that triggers immune response, but they all aim to prevent protection without causing illnesses. One of the oldest and most effective type is the live attenuated vaccine. These vaccines use a weakened form of actual virus or bacteria. Although the pathogen is still alive, it has been altered so that it can cause serious disease in healthy individual because they closely mimic a natural infection. Live attenuated vaccines usually offer strong and long-lasting immunity. Common examples include the MMR vaccine for measles, mumps, and rubella, and the varicella vaccine for chickenpox. Another common type is inactive vaccine, which use pathogens that have been killed or inactivated. These vaccines cannot replicate in the body, making them very safe, especially for individuals with weakened immune systems. However, they may require multiple doses or booster shots to maintain immunity. Examples include the polio vaccine and the hepatitis A vaccine. The more targeted approaches use the subunit, recombinant, and conjugated vaccines. Instead of using the whole pathogen, these vaccines include only specific parts, such as protein or sugars, that are essential for triggering immune response. Because they use only the needed components, they often cause fewer side effects. These type of vaccines are used to prevent disease like HPV, hepatitis B, and whooping cough. Toxoid vaccines take a different route. Rather than fighting the bacteria itself, they help the immune system defend against the harmful toxin that the bacteria produce. These vaccines are made from inactivated toxins called toxoid and are used to protect against illnesses like tetanus and diphtheria. More recently, scientists have developed mRNA vaccines, which use a small piece of the genetic code called messenger RNA. The mRNA gives instruction to the body cells to produce a harmless piece of the virus, usually a protein found on its surface. The immune system that recognizes and responds to this protein building immunity. This groundbreaker technology was used to create a Pfizer, BioNTech, and Moderna COVID-19 vaccines. Finally, viral vector vaccines use a harmfulness virus, often a adenovirus, as a delivery system. This vector carries genetic instruction into human cells, which then produce a piece of the pathogen that triggers immune response. Example includes the Johnson and Johnson COVID-19 vaccine and the Ebola vaccine. Each type of the vaccine has its own advantages, depending on the disease being targeted, the urgency of the outbreak, and the population being vaccinated. Together, these various approaches has transformed global health, providing protection against many of the world's most deadliest diseases. Teen childhood vaccines play a critical role in protecting children from serious and potentially life-threatening disease. These vaccines are given at a specific age during a child development to build strong immunity early in life, when children are most vulnerable to infection. CDC 2025. One of the first vaccines given is the hepatitis B vaccine, which protects against the virus that can cause liver damage. It is usually given shortly after birth. As infants grow, they receive a series of combined vaccines like Tdap, which protects against diphtheria, tetanus, and pertussis, whooping cough, three dangerous bacterial diseases. Another key vaccine is the polio vaccine, which has helped nearly eliminate polio worldwide. The HIV vaccine protects against Haemophilus influenza type B, a bacterium that can cause severe infection like meningitis in young children. The pneumococcal vaccines also help protect against meningitis and pneumonia caused by Streptococcus pneumonia bacteria. Children also receive the MMR vaccine, which protect against measles, mumps, and rubella, highly contagious virus infections. Around the same time, they get the varicella vaccine, which protect against chickenpox. The norovirus vaccine is given to an infant to prevent severe diarrhea and dehydration caused by the norovirus. As children grow older, they may also receive the hepatitis A vaccine, which protects against the liver infection spread through the contaminated food or water. As they reach their preteen years, children are recommended to get a HPV vaccine, which protects against human papillomavirus infection that can lead to a certain type of cancer later in life. They also receive a Tdap booster similar to Tdap and a meningococcal vaccine to protect against meningitis during adolescence. These vaccines are typically given in a schedule set by a national health organization like the CDC or WHO and are usually administered in multiple doses and ensuring long-lasting protection. Thanks to routine childhood vaccination, many once deadly disease has become a rare or even eliminated in some part of the world. Staying up to date with childhood vaccine is one of the most effective way to protect both individual children and the community as a whole. There is a strong and consistent scientific consensus that vaccines are safe, effective, and crucial for public health. This conclusion is based on the decade of large-scale study, real-world data, and ongoing monitoring by independent researchers and many major health organizations worldwide. A review by Zhu and colleague 2021 in the journal Vaccines examined key safety concerns related to the modern vaccines, including ingredients like aluminum, adjuvant, thimerosal, and even the long debunked claim linked to the MMR vaccine to autism. The author found no credible evidence supporting this concern. Instead, they confirmed that serious side effects are extremely rare and the benefit of the vaccination overwhelmingly outweigh any risks. Most side effects from vaccines are mild and temporary, such as arm soreness or low-grade fever. Vaccines go through rigorous testing in clinical trial and continue to be monitored even after they are approved and in use. The false claim connecting the MMR vaccine to autism began with 1998 study that has since been fully retracted, and the lead author was discredited. Numerous high-quality studies, some tracking hundreds of thousands of children, have confirmed that the vaccine do not cause autism. Leading organizations like the WHO, the Center for Disease Control and Prevention (CDC), and the Americans Pediatric AAP all agree vaccines are one of the safest and the most effective tool we have in medicine. In short, the scientific evidence is overwhelmingly vaccines work, they are safe, and they save lives. In conclusion, vaccines have transformed public health by preventing the spread of the deadly and disabling disease. They not only protect individuals but also create community-wide protection through herd immunity, especially for those who are too young or medically unable to receive vaccines. Extensive scientific research conducted over many decades by organizations such as CDC, WHO, and leading immunologists have constantly demonstrated that vaccines are both safe and highly effective. Zhu et al. 2021, WHO 2024. While mild side effects like fever or injection site soreness are common, severe adverse reactions are extremely rare. One of the most widely circulated myths, the claim linked to the MMR vaccine to autism, has been thoroughly investigated and scientifically debunked through large-scale study involving hundreds of thousands of children. CDC 2025, The Lancet Retraction 2010. To reiterate, scientific research over many decades has constantly shown that vaccines are both safe and highly effective. While minor side effects can occur, severe reactions are infrequent. Claim linking vaccines such as MMR vaccine to conditions like autism has been thoroughly investigated and completely disproven by numerous large-scale studies. In a world where misinformed information spread quickly, it is more important than ever to rely on trusted science and evidence. Vaccines save millions of lives every year. And by staying informed and up to date with immunization, we not only protect ourselves, but also the most vulnerable member of our community. Vaccination is not just a personal choice, but also a shared responsibility for a healthier future. Let's get vaccinated for the sake of our future generation. Thank you for your time. Thank you for your time.